Hello and welcome to Postgres FM. My name is Michael, founder of PG Mustard, and this is Nikolay, founder of Postgres AI. Hey Nikolay, what are we talking about today?
Hi Michael, you chose the topic under indexing, which means we will consider. You said this is the most popular case you see, like when people lack indexes, table lack indexes, not people, of course. Right.
Yes. Well, last week we discussed over-indexing and the problems that can come about because of that, and then that made me think. Wait, why are we covering this case when we haven't covered the case I tend to see more often, and I think is, at least in terms of raw numbers of companies or people, I think more people are in this boat, even if they don't think they are. And I think that might be an important thing. I think you said you were going to do a poll, or you might be about to do a poll on whether people consider that they are under-indexed or over-indexed. I think a lot of people have added a lot of indexes, but for their trade-offs, either some of those are not necessarily precise or optimal, or there are some duplicates in there. Maybe like they have a lot of indexes, but they still could afford to have a few more precise ones to really help their workload.
Right. Well, yeah, I don't have poll results right now, but right. So we think like over-indexing comes after you are in the previous position, under-indexing, right? So and then over-indexing and then precise indexing, like evolution of the state of your index sets. So yeah, I don't know, and the poll it's not representative. Even if a few hundred people answered, still we don't know. And of course, from my experience, when people ask us to help, like consulting practice, of course, we already see a lot of efforts to fix problems, and obviously sometimes too many indexes created, and obviously this is not this is the state, not initial one. It's already some developed situation. So yeah, I agree with you that under indexing is also interesting topic, maybe more basic, but worth discussing.
Yeah, and I've actually just realized, I probably should have realized this earlier, that it's possible to be both at the same time, right? Like you could bring in a consultant, they remove 10 indexes and add 2. Like it's possible that you're missing the perfect indexes, but also have way too many indexes. So maybe it's a bit oversimplistic for me to say.
And interesting that from if you come to some project, removing indexes is easier. It's a simple task actually. You check duplicates, you check redundant, unused indexes, right? And this is easier than finding proper indexes when it's when some tables are under indexed, because you need to analyze workload, and this is more complex research basically than just checking for redundant or unused indexes. I mean, those types of research also not super trivial. They have some complexities. We discussed them, but finding proper indexes may be more difficult problem. What do you think?
Mm-hmm. Finding them is interesting. I think there are some pretty simple cases of finding cases of being under-indexed as well. But clearing it up, I guess especially now that we have drop index concurrently, it's quite easy to clean up. There's not much risk to cleaning up indexes. Whereas adding an index, and the downsides aren't as, like, if you're dropping an index, as long as you're confident it's not being used, you're only seeing upsides. Whereas adding an index, you have to convince people it's worth it as well. Maybe I'm not sure. To be honest, I think I'm not sure we're ever in a situation where we're really having to choose between these two. Normally, it's a case of quite a clear-cut win. But on that, like, before we dive too much into specifics, should we go through a few of the, like, how would somebody know? What are some signs that you might be in a situation where you are what we're calling under-indexed?
Sequential scan. My main first sign. You see sequential scan, and actually, if you see it, maybe first thing you need to do, not just go and create index, but first you need to check your Postgres settings, because still I see many managed Postgres service providers. They do bad job pre-configuring Postgres clusters. I see random page cost being 4 in so many places still.
Yeah.
They give you SSD disk and keep random page cost 4, which is for magnetic disks. And this is first thing you need to check if you have sequential scans more often than you expect in the scan, but you see sequential scan. Even if you don't have index yet, it's worth first checking this thing and only then start creating indexes, because otherwise you might see you created index, but it's still not used, because if random page cost is 4, it means that Postgres will prefer sequential scans more often, right?
Yeah, I thought this. I was actually quite surprised when somebody I know was migrating from a provider that tuned it a little. They tuned it down to 2.0, not as low as you might suggest, but they were moving to a provider who didn't suggest copying across the config and had the setting as 4.0 and saw no issues at all. So I
I
do
have a
think
fresh case. Let's
go
drop some
on.
names. Crunchy
Yeah.
Bridge.
Yeah.
Crunchy Bridge,
4.0.
I said great, like super cool that they provide real super user, unlike most of the others, but they also keep random page cost 4. What's happening there?
I don't know. I think they make a good point that it's, well, in a way it's not that important, right? Like the difference between like it's important for some subtle cases and for some cases where we're scanning a lot of rows.
Edge cases, probably, right?
But yeah, but for the standard like primary key lookups, it doesn't make a difference. As soon as
I
you're
agree, but edge cases happen more often than we would like to have them, right? So
yeah, and as a managed provider, I think
slightly more complex query, and you already had this problem.
Yeah,
I encounter with this problem very often. Like we start optimizing, and this like I myself forget about it. That's why I'm raising this as a first thing, because I found myself in this position when I said like spend some time and then realizing, oh, random page cost 4, so many times already. Like I can count like 10 times maybe during last couple of years. So it's a lot already. and we should fix it first and then move forward, I think.
Cool. When going back to what you mentioned, sequential scans, do you mean, let's say in the like statistics we're looking at, like in the system views we're looking at the percentage of sequential scans done on a table, or do you mean like looking at a single execution plan of a slow query and it's using a sequential scan?
Well, here you touch the topic of lacking the tools to analyze workload more holistically, because we can, like, if we don't have auto-explain enabled, PG-star statements don't have plans, and you might guess that there is sequential scan looking at buffer numbers, right? Compare them to calls and think, oh, so many buffer numbers, maybe sequential scan there. But of course, I'm mostly talking about explain and analysis of a single query. So.
But we can also look up one of the PGStat user tables. We can look at the proportion of queries that use sequential scans versus index scans. That could be like if you're under index, you might see a decent percentage.
Actually, you are right. Yeah, at table level, not at query level, but at table level. Yeah,
exactly.
Good point.
That's one of the starting points that I would look at for like seeing if somebody is like thinking about overall they just haven't added that many indexes. That's going to be a real telltale sign there. But I was thinking even higher level things, like maybe they're saturated on IOPS, or maybe they have high CPU all the time. Like there might be some system-wide effects of doing a lot of these table scans as well, right?
Right, so it's a good point. Analysis of PGStat user tables, it's a good idea, but also worth remembering that some queries do need sequential scan. For example, dump or some reading whole table, select count star from, select count star is already index scan, maybe index only scan, right?
Yeah, but you're right. Like this is actually probably worth mentioning quite early on that, I mean, I actually haven't looked at the percentage recently, and it will depend on like the size of the table, like the number of columns and things. But if you're scanning more than, I'm going to put out a number there, and this is wrong, but like it's roughly in the right area. If you're scanning more than 20% of a table, chances are a sequential scan is going to be faster, or at least as fast as an index scan, and less expensive.
It depends.
Overall.
It depends.
I know.
Because Yeah, select count. If it's even whole table scan, you need all rows, count all rows. Index only scan will be much faster than counting with sequential scan, obviously. So
Yeah.
it very depends. That's why honestly, I forgot about registata user tables because I don't use it too often. I
Interesting.
usually prefer switching to next layer. This is very top level. Of course,
Yeah.
if you go from top to bottom, it's great. You start with like looking at tables. Each table has a lot, participates in many queries, but I prefer going second layer queries, so persistent statements. And there we don't have the counter related to plans, and each query uh, might have multiple plans depending on parameters. So auto explain is good. And this is like anyway. Let's maybe skip it. We discussed this query analysis in other episodes. But the bottom line, sometimes you do need sequential scan. For example, if you dump, it's
Yeah.
inevitable. But in many cases, if it's sequential scan, you probably need an index. Unlike as you said, unless as you said, we need to read too much of the table. So words cardinality and selectivity, to these two words are important to understand. If selectivity is bad, means that cardinality is high, and we read too many rows. Sequential scan maybe is fine, right?
Yeah. And the other exception is tiny tables. Like if you've got less than 100 rows in a table, like a lookup table, and you see like a
How
high
many rows
percentage of,
you mentioned?
I said 100, but let's say 10. Like let's use a number that you can't
10,
fight me about.
10,000 or just 10?
10 rows. Like we're
Okay.
talking about a little lookup table, for example,
Right.
and you see 100% of scans of that table are sequential scans.
Right.
Not a problem. Like just
Right.
not an issue.
Right. But thousand rows, maybe in the scan already will be
Yeah,
better.
I would
Slightly,
guess.
very small difference between these.
And actually, all of the things I mentioned are not a definite sign that you're under indexed. Like high IOPS, high CPU, they could just be like system load. It could be you could have perfect indexing and still have those issues, but they could be a sign. Like you said, high number of sequential scans isn't a sign that you necessarily are under indexed, but it might be like it's a clue rather than a piece of evidence.
Right, but
And I
looking
think,
at a single plan, if you see sequential scan, when you know
yeah,
that you just read one row out in a billion row table, this is a strong sign. You need an index.
exactly. If it's an important query, if it's a query you repeat over and over, or like if it's not one you're running like once ever and then never needing again.
Yeah, trade off, right? You think
Exactly.
if
But yeah, I've got a couple of others that like might be useful to think about. So we've got the high IOPS, high CPU, low index scan ratio. Also, like low cache hit ratio could be a sign. Like if you're using indexes nicely, chances are you are going to see more things being read from. There are these signs that you are under indexed that aren't giveaways, but they're clues that you might be. And then a couple of other more obvious ones are slow deletes. If you're seeing that, there's a decent chance you're missing an index, and slow
before
joins.
this is
Oh,
already like you dive to some specific topic. I mean, it's not very uncommon, but before we consider this, how about mentioning that you might have index scan, but it's still underperforming, and the
yeah,
sign of it, if you see in the plans, filter.
yeah,
Some rows were filtered out because like index was created for different queries, basically. It works, but finds too many rows, like extra rows.
yeah, exactly. And this takes us back to the first thing you mentioned, which was sequential scan. So if we're looking at a query that we think is slow, or is maybe one of our most common queries, or we're sorting pgstat statements by total time, and we're just looking at the execution plan of one of those, and we see either a sequential scan with a large filter, or as you're mentioning, an index scan with a large filter, then there's a chance that's not optimal for our workload, and we'd be better off with either an index in the case of a sequential scan, or a better, like a more precise index for that access pattern.
Right. Right. So I also don't like filtering. So,
But there's something again. You might say I'm diving too much into the weeds here, but there is something slightly different about these two. With sequential scan, it can be really obvious. The rows removed by filter tends to be quite a large number. Not always the exact number you're filtering, because chances are if you're doing a large sequential scan on a modern version of Postgres, it will be parallelized at least. So the number you're seeing will probably be 3 times lower than the actual number being filtered, because you have to multiply it by the number of total threads, or I don't quite know how to describe it. Number of workers plus the main.
Right.
Yeah, but plus the main one, right? So what do you call those 3
It's
combined?
confusing. If you see 2 parallel workers, it means 3 workers already, right?
Yes. So that number can be already big though, and it sticks out in plans. Whereas sometimes with inefficient index scans, we might be like in a nested loop, for example, with thousands of loops, and that number removed by rows removed by filter could say just 1 or 2 or
Not
5
inside the loop, right?
But you have to multiply it by that number of loops to realize the proportion. And if it's the difference between rows removed by filter and rows returned by that node, the actual rows returned, is the giveaway there. And if you multiply it by the number of loops, then you get a really good idea of how inefficient this is being, and therefore, could we think of a better way? But the key takeaway, you're probably not going to remember all of that if you're listening to this for the first time, but if you just please don't just see an index scan in your query plan and move on and assuming it's the most efficient thing possible.
So that's sequential scan is one sign, filtering in the not our index, someone else's index is a different case. But there is also, you see index scan, maybe no filtering, but also top end sort or something like in memory sorting.
Yeah,
because and you could do better if index combine a couple of columns, which one, for example, is to support filtering the where clause, right? And second is to order by. For the example is like filter by date and then order by name, or filter by name, order by date, for example. If you combine both columns properly in proper order in the same index, in a single index, it will be just one single index scan, and that's it. No memory sorting. So this is yet another a sign that probably you need to think about different index, right?
Yeah, absolutely.
In addition to filters, filter with large numbers.
Yeah, and that's another good point actually. If you consider the general access patterns of OLTP systems, for the ones that we tend to see more of, I think people start with single column indexes when they're learning about indexing, and there's only so efficient you can get with those. Maybe that trade-off is perfect for your system, but chances are that you're going to have some access patterns that return a couple of rows, a couple of different columns. And for those, you're never going to be able to compete on efficiency with single column indexes, even though Postgres does have some optimizations around that, than you are with a precisely ordered multi-column index. And the key takeaway from me there that I still see people getting confused about is the order really matters. Which column you put first really matters. Which column you put second really matters, and onwards.
Let's consider this simple example, which is very, very common. You filter by, I don't know, like by some city, for example. You filter by city and order by, I don't know, by ID in descending order. So if you have two indexes, one on the city ID or city name, if you put the name and the second is on ID primary key. These two indexes cannot work together well here. So Postgres will decide to choose which index to choose, and then perform additional either filtering, or if it's chose index on ID, or if it chose index on city ID, then it will be this top end sort in memory. And in this case, you just need which index? You need index on city ID and then ID, right?
Exactly.
First filter, then order by.
And the opposite order, ID and then city, would be pretty useless for that query, which is interesting.
And also if you created I mean, it will be useless because because order by is executed after where, or where comes before it. So we need the CTID to be in the first place on this two-column index. Also, if you create this index, you can drop an index on CTID.
Yes. So that we can refer
This is
people
what people
back to
forget.
yeah
Back to the previous episode, exactly.
previous episode for having too many indexes.
Good. So this we discussed basic things. Now, like we move to the area you started to raise when you said foreign keys and so on. But I would say there are many cases, and foreign keys is one of them. When we talk about we need this index, but not too often. And this is like difficult because you need to decide. Because if you delete from a table and want to have it executed fast, but you do it only once per year, maybe you don't need to keep the indexes which support this delete, because the indexes occupy disk space. They slow down updates and inserts, as we discussed, and they even slow down selects, as we discussed. I mean, planning time. So, or not only playing time, if you achieve 16 locks, execution is slowed down as well. So maybe you don't need those indexes. But so every time you need to decide, okay, I have this report, for example, or this delete with foreign keys, cascaded delete, right? But it's executed once per week or month or year. Do I need those indexes? Or maybe I need to create indexes and then drop them. I don't know. When we do some cleanup, some temporary indexes. So it's interesting because there is trade-off here, and there's price you pay for indexes. And I'm again like echoing our previous episode, right? But let's consider particular examples of some cases. Like foreign key is interesting one, right?
Yeah, I don't think I said foreign key. I love that you jumped straight to it. I think I was giving specific examples
Support
where
deletes. Okay.
Yeah.
Well,
But
if you
maybe the mistake I made was saying slow deletes, because what I should have said is slow queries. Like it's the sign that you're missing an index. The first sign is like the web page is slow for users. Like that. These are like the. I know we're back to basics, but it's slow deletes are a subset of slow queries in general, right? Like it's the slow query, and the slow delete is one I mentioned partly because I think it doesn't fit into the other categories, because we can see a slow delete without a sequential scan. We don't see the sequential scan in the execution plan. So it was more that it's
you mean delete, cascaded delete. When we have delete on the main on some table, it works using some index scan. It finds rows to delete using some index scan, but it also needs to propagate deletion to reference sync tables, so which have a foreign key to us. And in this case, if we don't have special index on those tables, Postgres will need to perform sequential scan on that table to find all rows which reference to row we delete in the main table. And this is a bad situation. Many DBA kits, toolkits, include a special report to find such under-indexed foreign keys. Usually on one side of foreign key, we have primary key usually, right? It's okay. But on the other side, we sometimes don't have it. And if we think about it, like this is the area where a reactive approach doesn't work well, because probably you will like live quite long without encountering this plan at all. And then someone decides to delete something. For example, delete some user and all data this user produced. Very common case. And suddenly, if you don't use some asynchronous approaches, you want to delete everything. Maybe it's not a good idea, but it's a different story. In this case, suddenly, like you didn't delete anyone during a couple of months of your project. Then suddenly you try to delete, and it works very slow. So proactive analysis of such situation using that report and creation of indexes proactively here might be a good idea, right? But it depends again. It depends a lot on your use case.
I understand it. Mm-hmm. I was just gonna say that I think it surprises some people that Postgres doesn't index foreign keys by default. So you can define it as a referencing, but you like with the primary key, we get the index implicitly behind the scenes to guarantee uniqueness. but it means we can use it for lookups as well. But foreign keys, we don't get indexed by default, but some frameworks do. So like, what are you going to say?
Well, indexing foreign keys sound strange to me because, like, again, we have two ends of foreign key, right?
So yeah,
one end, indexing of one end,
adding an
so,
index to the referencing
right?
take column. Yeah,
Right.
but Django, for example, if
Uh-huh.
I add a second table with a, well, it's not called that in the Django world, but if I add this into my model, I'll get an index on the original table
Right.
added for me. And I
Right,
think
but
it's quite a sensible default for
yeah,
OLTP.
yeah. But I think this also a case when, again, like, this is a case when we need some proactive analysis and
Mhm.
understanding trade-offs. There are many such cases, a lot of such cases. For example, we have monthly reports, right? And and we didn't prepare indexes for such reports, or I don't know, like, for example, we have very high flexibility in our UI, allowing people to filter on too many, like, in extreme case, we allow users when working with data, we allow them to order by anything, to filter by any column, combinations of them. And this is like the worst situation when we try to understand which indexes we need. And for example, currently, like, we analyzed last week, we're doing fine, but it doesn't matter that somebody, like, tomorrow somebody won't filter on something new which wasn't used before, and this is not covered by any indexes we have, right? So I'm trying to like say we have situations when it's hard to predict all possible cases, and things like ORM or GraphQL, they give power to users, but this power needs to be supported by indexes. And you can say quite like that this is very high probability that if you take some project which says we give full freedom, full flexibility to our users, you can say most likely this project is under-indexed because you can find some situations when we don't have index and we like have sequential scan, for example, right?
Yeah.
What to do in this case?
So, I mean, we're getting close to the point where we're saying what to do when you're almost optimally indexed and you've got a decision to make. I personally think that most people aren't in that situation, and the overhead of adding another one is going to be worthwhile. But as we've discussed in the previous episode, if you take that to its logical conclusion, you're going to end up in a situation where you have probably more indexes than is optimal. But maybe you're dealing with more complex situations than I am. But I think a lot of applications are quite simple. Like a lot of applications only have a certain number of access patterns to each table, and you cut once you've got a few indexes that are really precisely for certain features. You're probably going to be fine until you add a new feature or until you scale beyond a point where, like we talked about in the partitioning episode, like where you have to make a bigger change. So yeah, I think adding a new feature is a good case where you should reconsider. But maybe I misunderstood what you were saying. There was a little bit of choppiness.
Right. So let me repeat. If you have some application with strict usage patterns, you understand how exactly users can use which queries they can produce under the hood. This is okay. Like you can build proper set. You can find very good set of indexes and then just slightly adjust, revisit it from time to time. But if you build some platform on top of Postgres, for example, an extreme case like no code platform, which provides like very flexible way for or even developers, and you build like some REST API, GraphQL or something, and you give a bit like full freedom, filter by anything, order by anything. All columns are possible. Like build a table with 100 columns and use all of them to filter, order by. and like do it on client side from browser or something. This is extreme situation, and you don't know in advance. You don't know which indexes you will need.
Yeah.
Right. This is a bad situation, and obviously you are under-indexed because you cannot create index on each column and then 2 column indexes on each combinations. It's like it's a bad idea.
Yeah, well, this reminds me, I think when we tweeted probably the last episode, it must have been the last episode, somebody replied saying, I came across a client recently that had 50 indexes on on this specific table. Is that a new record? And then somebody else replied with one of
Heap.
Heap Analytics blog posts. So Heap are kind of in that situation, right? They let people dump like it's analytics data, right, into Postgres, and they don't know what people are going to want to look up and order by and sort. So that's effectively a custom analytics product on top of Postgres, right? So I would probably direct them at this
Right,
Heap
but
Analytics.
it was not many columns situation. They keep. This is old but very interesting article. They indexed. They created a lot, like how many? 100,000? I don't remember.
Millions.
Millions of indexes.
Yeah.
But partial ones. So they indexed like some rows, not whole table, some rows of it. And they also decided to go with create index without concurrently. They explained why. I don't remember. It's an interesting article, but it's a special case.
I think it's because you can't do more than one create index concurrently at the same time.
Yeah, maybe because of that, right? Mm-hmm.
Yeah, which when you're doing millions is a problem.
Right. Interesting, yeah. So, but it's not what I'm talking about when we have many columns and we need to expose this table via a REST API or GraphQL and allow end users to choose which like filtering and ordering, and this is bad. I mean, this is a hard problem to solve.
Did you? I'm not as familiar with that as it sounds like you are. But there was a blog post not that long ago from Cybertech, I think, talking about a new extension, I believe, that was to do with this kind of like it was. I think it was designed, or the example they gave was for like an online shop that wanted to let you filter by any category. Like you want to pick men's t-shirts and then color, and at each stage they wanted to give you a count of how many there were in those categories, and it was like a new algorithm for getting those counts quickly on any custom data set. So I'm guessing there's something in that.
It's called faceted search, right?
That's it. Yeah.
Right.
Is that related?
Yes, but if you're building e-commerce system and need this, it's solvable problem. I'm talking about platform for people who don't want to dive into index details. For example, think about Supabase, for example, right? But maybe even more like people who don't understand databases and don't understand indexes, and they need to visually create tables and then build some mobile app or something. This is not good. Like this, you probably still need to think how to restrict the freedom, right? And think about indexes. Without understanding indexes, probably you won't achieve good performance if you have a lot of data, right?
So you're saying as a platform provider, how much should you index things by default and how much should you let the users have like power to do that kind of thing?
Yeah. So maybe you need to restrict the paths, and maybe if you have GraphQL, maybe you need to restrict possibilities it provides.
Yeah, I mean, this is just a strict trade-off, right? Either you restrict things and try and give a certain amount of performance as a minimum, or you accept poor performance, or you have something in between. Like I've seen one product, for example, land on saying if a query takes more than like if a user's changing a dashboard and it takes more than a few seconds to load, say to the user, could you restrict it a little bit more? Could you filter down to a smaller date range or something else to give it a chance of doing a faster scan? So there are like user facing things you can do, I think, in those situations, but we're in the strict trade-off land, aren't we?
Right. I'm just trying to say if you want to avoid indexing topic, maybe you won't solve the problem. You need to understand indexes and you need to make some decisions, probably leading to some restrictions.
Yeah, I
because
think
this,
so.
yeah, good. And what else? Like how to build indexes faster? Maybe, or what do you think? How to build indexes faster?
Honestly,
If you want,
I think this is enough. I think a lot of indexing stuff
okay, let's
aimed at,
talk another time.
yeah, there's so many articles I see go into kind of the different index types, and they go into partial indexing and index on expressions. And it gets complicated fast, but honestly, the basics are, well, I guess they're the basics for a reason, but I think you can get a long, long way just with single and multi-column B-tree indexes.
Right,
But
right.
yeah, obviously everything else could be left for another day.
Right, or gene index for some more complex data
Yeah.
like JSON or arrays. But again, like let's finish with a reminder that if you decided to add an index, also consider the cost, the price you are going to pay
Yeah.
for it. It's not only storage; it's negative effect of existing queries. It will be small, but in some cases it's significant, especially if you had hot updates, heap only tuple updates, and then you create index and lose them. Updates can be significantly slower, and heavily loaded system it may be very noticeable.
And if you're in a even moderately loaded system, you probably don't want to just create an index. You probably want to create index concurrently.
Right, but we agree to discuss this next time, how to speed up and do it right and so on. Okay, let's do
That's
so.
how to slow it down, but how to keep it safe.
Right, 2 times slower. Right. Okay, good.
Nice one. Thanks so much, Nikolay. Thanks everyone.
Thank you.
Catch
See you
you
later.
next
Bye.
week.
Bye.
Bye.